obtain the Fourier series for the function f of x is equal to under root 1 minus cos x in the interval minus pi to pi. So here solution, first of all write down the given function f of x is equal to under root 1 minus cos x. Now the intervals are minus pi to pi. When the function have like this, we need to find the given function. This function is even function or odd function. So first of all verify the given function is even function or odd function. For that, let f of minus x is equal to under root 1 minus cos of, here we have x, so negative x. We know that cos of minus theta is cos theta, so this is equal to under root 1 minus cos x. That will be the f of x. So f of negative x is equal to f of x. So this is the even function. So the given one is even function. So when the given function is even function, automatically bn value is 0. We need not to find bn value because it is 0. Just we need to find a naught and an values. For that, we have to use Euler constant. So first of all, Fourier series formula is f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx. This is the Fourier series formula. Consider it is equation number 1. Now we need to find a naught value by using Euler constants. A naught is equal to, formula is 2 by pi. When the given function is even function, so you need, formula is 2 by pi integral 0 to pi f of x dx. So that is equal to 2 by pi integral 0 to pi f of x. F of x means the given function, that is equal, that means under root 1 minus cos x dx. Here observe 1 minus cos x integrand value 1 minus cos x by using trigonometry, by using the trigonometric of angles, that is equal to 2 into sine square x by 2. So 1 minus cos x is equal to 2 into sine square x by 2. This is trigonometric of angle. So substitute 1 minus cos x is equal to 2 into sine square x by 2 here. That is equal to 2 by pi times of integral 0 to pi under root 2 into sine square of x by 2 into dx. Now split the root value to constant as well as the trigonometric function. That is equal to 2 by pi into integral of 0 to pi root 2 into root sine square x by 2 into dx. Here square root cancel, root 2 is a constant, take it common. That is equal to a naught is equal to 2 root 2 by pi times of 0 to pi sine of x by 2 into dx. We know that integral of sine ax dx is equal to negative cos ax by a plus c. So if we compare these two, here x coefficient is a, here x coefficient is 1 by 2, 1 by 2. That is equal to, already here we have 2 into root 2 by pi times of negative cos x by 2 by 1 by 2, where the limits are 0 to pi. Now here taking common minus and pi by 2, that is equal to 2 into root 2 by pi into 1 by 2 whole. Now substitute the upper limit in x place as well as the lower limit. Then it is cos of pi by 2 minus cos of 0 by 2. that is equal to, this is 2 2s are 4, negative 4 root 2 by pi whole into cos pi is 0 minus cos 0, this is 0 by 2 is 0, so this will be the 0. So this is cos 0 degrees, so cos 0 is 1. Since cos pi by 2 is equal to 0 and cos 0 is equal to 1, so now this is a naught is equal to minus into minus plus 4 root 2 by pi, this is the a naught value. Now we need to find an value. A naught is equal to 4 root 2 by pi, keep it aside. The next we need to find an value. An value formula is 2 by pi integral 0 to pi f of x into cos nx dx. This is the a naught formula. So here n is equal to 2 by pi times of integral 0 to pi, f of x value is under root 1 minus cos x into, already here we have cos nx dx. Now again we have to apply the trigonometric of angles formula here, that is equal to an is equal to 2 by pi times of 0 to pi, here this will be the under root 2 sine square x by 2 into cos nx dx. Now split the root value here, then it will be root 2 into root of sine square x by 2, square root cancel, so substitute here, that is equal to, already here we have 2 by pi times of 0 to pi integral 0 to pi, this will be the root 2 into sine x by 2 into cos nx dx. So here root 2 is constant, take it outside, and next this will be 2 into root 2 by pi times of integral 0 to pi sine x by 2 into cos nx dx. So here 2 is constant, bring it to here, that will be, then it will be root 2 by pi times of integral 0 to pi 2 times of sine of x by 2 into cos nx dx. So this integrand, if you observe, this integrand will be like this, 2 sine a cos b is equal to, formula is sine of a plus b plus sine of a minus b. If we compare these two, here is 2, here also 2, sine here is a, in the formula we have a, here is x by 2, so a is equal to x by 2 into cos, here also cos, in the formula we have b, here is nx, so b is equal to nx. So substitute where a is equal to x by 2 and where b is equal to nx, that will is equal to an is equal to, already here we have root 2 by pi integral 0 to pi sine of, substitute this formula, sine of a plus b, a value is x by 2, that is x by 2 plus b value is nx plus sine a minus b, a value is x by 2 minus b value is nx whole into dx, that is equal to, now here split the integral first one and second one, root 2 by pi whole into integral 0 to pi sine of, here taking x common, 1 by 2 plus n into x dx, plus here also integral 0 to pi sine of, here also taking x common, 1 by 2 minus n into x dx. We know that integral of sine ax dx is equal to negative cos ax by a. If we compare the first one, here x coefficient is 1 by 2 plus n. So a value is in the first one 1 by 2 plus n. Substitute a n is equal to, already here we have 2 root 2 by pi whole into integral of this one. So it is negative cos ax by a, but a is equal to 1 by 2 plus n. Negative cos of 1 by 2 plus n into x by a value is this one, 1 by 2 plus n, plus again the second one. Here second one is, instead of a, here we have 1 by 2 negative n. So here a is equal to 1 by 2 negative n in the second one. So it is negative cos of 1 by 2 negative n into x by 1 by 2 minus n whole. See here both limits are equal, so 0 to pi. That is equal to an equal to, already here we have root 2 by pi times of negative cos 1 by 2 plus n into x whole by 1 by 2 plus n, plus into minus minus cos of 1 by 2 minus n into x whole by 1 by 2 minus n, where the limits are 0 to pi. Now substitute upper limit in x place minus lower limit in x place, that is equal to, then it will be an equal to root 2 by pi times of negative cos of 1 by 2 plus n. Here we have x, substitute pi value, pi upon 1 by 2 plus n negative cos of 1 by 2 negative n. Here also we have x, so replace x with pi by 1 by 2 minus n minus, now substitute lower limit in x place, negative cos of 1 by 2 plus n into 0 by 1 by 2 plus n. So here we have negative cos of 1 by 2 minus n into x, again substitute the 0 by 1 by 2 minus n. See here cos of 1 by 2 plus n into pi value is 0, and cos of anything into 0 is 0, that is equal to, this is 1. So an is equal to, already here we have root 2 by pi times of negative, this total is 0, 0 by anything 0, so just you have to write 1 by 2 plus n minus, this is also 0, 0 by 1 by 2 minus n. The negative, see here, negative into negative positive, this total is 0, 0 into this total is 0, so cos 0 is 1, 1 by 1 by 2 plus n, again 0 into, sorry, minus into minus plus, this is also total into 0 is 0, cos 0, cos 0 value is 1, 1 by 1 by 2 minus n. So this total is 0, means 0 by anything is 0, 0 by anything is 0, these two are 0, so need not write these two values. An equal to under, sorry, root 2 by pi whole into, so 1 by 1 by 2 plus n plus 1 upon 1 by 2 negative n. Now here taking LCM, that is equal to root 2 by pi whole into, LCM is a plus b into a minus b, a square minus b square into cross multiplication, 1 into 1 by 2 minus n, 1 by 2 minus n plus 1 into first denominator, 1 by 2 plus n. See here negative n positive n cancel, the remaining is root 2 by pi whole into 1 by 2 plus 1 by 2. Of plus of is 1 upon a square. That means 1 by 2. Sorry, 1 by 2 whole square means 1 by 4 negative n square. That is equal, therefore an is equal to, see, that is equal to root 2 by pi times of 1 upon, see here, taking LCM here, so 1 minus 4n square by 4. So this denominator goes to the numerator. That is equal to root 2 by pi times of 4 into 1 minus 4n square. Therefore an is equal to 4 root 2 by pi into 1 by 1 minus 4n square. This is the an value. We successfully found a naught and an value. Now substitute those values in equation number 1. So first of all you have to write equation number 1, that is f of x is equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx. This is the equation number 1. What is a naught? A naught is equal to 4 root 2 by pi, and an is equal to, this is a 4 root 2 by pi into 1 by 1 minus 4n square. 4 root 2 by pi into 1 by 1 minus 4n square. This is the an value. So substitute these two values in the formula and f of x. What is f of x? F of x is given function, that is 1 under root 1 minus cos x. Substitute these three values in the Fourier series formula. Therefore this will be f of x. F of x means under root 1 minus cos x is equal to a naught. A naught value is this one, 4 by root 2 by pi whole by 2 plus summation n is equal to 1 to infinity. Now an value, this is 4 root 2 by pi into 1 by 1 minus 4n square into cos nx. Therefore, or this is the answer, or you may write like this also, 1 minus under root 1 minus cos x is equal to, this is 8 root 2 by pi plus, taking this common, 4 root 2 by pi into summation n is equal to 1 to infinity 1 upon 1 minus 4n square into cos nx. This is the answer of the given question.